Okay, so I'm representing security and privacy, but I'm going to focus a little bit about what we are doing recently, and tell you a little bit about the last few years what we have been doing on trustworthy machine learning. And we are part of a big NSF center, which is, you can go to the link over there. If you're interested, so the people in that center are from Stanford, Virginia, Penn State, UCSD, Berkeley. So it's a big center that is pushing this effort. Okay, you will hear overall today probably a lot of talk about machine learning taking over everything like healthcare, transportation, energy, education. So I'm not going to belabor the point. You're going to hear that quite a bit. So 2013 is when there was a little bit of an inflection point where machine learning started beating humans. Okay, and people started getting really, you saw these articles coming out like, hey, your jobs are going to be gone and so on and so forth. You know, maybe in 10 years there's going to be machine learning algorithm giving the security privacy introduction talk, right? So, for example, they were able to beat recognizing objects in cases, breaking captures. This is why I don't know how many have seen the captures are getting weirder and weirder every year. And I have actually issues sometimes solving them. It's like, okay, is that a street sign? I don't know. And this is for my parents. My parents still hold a grudge that I didn't become a real doctor. And so this is a slide just for them. Essentially, there are a lot of articles that are coming out that for a lot of things like radiology, machine learning is actually beating real doctors. Okay? And machine learning is also used in cyber physical systems like robots, drones, and so on and so forth. Okay, good. So if everyone in the world was good, this will be a very short talk. I will just walk off right now. Right? But in security, we are very glad that they are really bad. Okay? That try to screw up your system. So everybody's not good. And machine learning is deployed in a lot of adversarial settings. So there's a very interesting case. How many of you know about the Microsoft State chatbot? You know, some of them you know. Right? So essentially you can poison the data set very little and it starts tweeting some crazy things. Okay? And you can craft out very well-crafted videos which, you know, can go through YouTube filtering. And it is not great content. Okay. So in security, we talk about two types of attackers. One is an active attacker. So for example, poisoning the data set. That's an active hack. The other, what we call is honest but curious. So imagine a medical researcher running a machine learning algorithm. You know, they're using it in a very legit fashion, but then what they try to do is try to infer some sensitive information from just the output of the machine learning algorithm, like sensitive gene types and so on. So in that case, they're not doing something actively bad, but from the machine learning algorithm, they're trying to infer something they shouldn't be doing. And that's what we call honest but curious. Okay, I know that's not a great term, but that we use this a lot in security. So to me, when you talk about attacks, think about those two things: active attackers and honest but curious. Okay, so here is an active attack. This is a stop sign. This was a work that was done by Michigan and Berkeley, where they actively defaced a stop sign. So this is to you and me doesn't look a stop sign, but most of the object detectors say that this is a speed limit of 45. So you can imagine an autonomous driving car, if you're using one of the object detectors, it says this is 45 speed limit, I'm going to keep going. Okay? Now, the example of the second kind is like privacy breaches. So for example, in AOL, which is a defunct company now, but many years back, and also Netflix, they had these challenges where they sort of put data sets out there, and people were able to use these anonymized data sets to de-anonymize people. So for example, there was this lady from Boston who was de-anonymized. So that's what I mean by honest but curious. It was not that people were using the data set badly, but they were able to use these anonymized data sets to de-anonymize somebody else. Okay, so let's get into the active attacks. So in a very high level, a machine learning algorithm, you have a training data set X, you run some learning algorithm, neural network, or so on, you get some parameters, and then you get an actually trained model, and then you're feeding it test input, saying, hey, is this a cat or a dog or something, and you get sort of output. And all of these steps have been attacked. Okay? And people have looked at all of them. So for example, you can poison the data set to learn something weird. That's what we did with the Microsoft chatbot. You can feed adversarial input so that the machine learning algorithm makes mistakes, like the defaced stop sign. And you can do model theft, which is a new thing that people have been looking at. We recently have a paper in it. So if you see Google, Amazon, you can put machine learning systems on a cloud, and then people can query. These are called machine learning as a service. But if I can get very few queries, reverse engineer what is in the cloud, well, then the whole business model is gone. Okay? Okay. Now there are some attacks which I didn't put on this thing because I don't know how to classify them. So there are these attacks which I call fake news attacks, where you can use these generative models like GANs to actually get videos of Obama saying like he's a Muslim. And actually it was really amazing. There was a class project in my class and somebody showed me a video of me saying crazy things, and I couldn't tell that it was not. Okay, so you can imagine this is used in sort of these social troll campaigns and so on. Okay. Okay, so let's get into some of these attacks, and then we will get. So this one is a training set poisoning attack that I got these slides from Jerry Zhu, who's probably going to talk later. So this is the Lake Mendota ice days, and these are how many icy days were there in each of the years. And you want to fit a line through it, and the line should go up or down. If you fit a linear regression line, the number of icy days should be going up or down. What? Somebody said something. Down? Because of global warming, it's probably going to go down. But hey, I'm a climate denier, so what I can do is change very few of the points and make the line as it is going. Okay, now let's get into this. This probably is the most crowded area right now. A lot of people are working on it. And an adversarial example is basically an example that the attacker generated to intentionally make the model make a mistake. Okay? So for example, this is around the same time that, remember all those things were going on that, hey, the machine learning algorithms are beating humans. And people started noticing that, hey, this is really weird. Some weird stuff about machine learning. So the idea was they took one of the best models out there and were able to add some very small crafted noise so that the machine learning model was making mistakes. So for example, a panda was being classified as a kid. Okay? And there are galleries of these examples now. So for example, in this case, school bus was being classified as an ostrich. And my favorite from last year's ICML, cat being classified as a guacamole. So my wife is really into making homemade guacamole. So this was a nice example. Okay. And the adversarial examples have gone beyond deep learning and beyond vision and so on, and I'm not going to talk about that. Now coming back to honest but curious, what we are looking at is, if you look at a lot of, we have a big machine learning department that works with clinics. And these clinics don't want to share data at all, because that's their proprietary thing. They are worried about privacy and so so on. But there is benefit of combining these models and building some models for healthcare and so on and so forth. Okay? So there is a very interesting case from Ford Bridgestone. How many of you remember a few years back there was this Ford Explorers that used to overturn, right? You remember that? It's like a huge thing. And the idea was that there was some bad interaction between Bridgestone tires and Ford Explorer. And people later did an analysis that if they had just combined their data and did a sort of some machine learning algorithm, they would have found that issue. But because of business concerns, privacy concerns, they didn't do it. Okay? So the idea is here, we want to share data, but people don't want to do it because of privacy concerns and business concerns. Okay, so we have a very interesting thing which we can't get into too much detail, where clinics like Marshfield Mayo can encrypt their data. It sounds like magic, right? They encrypt, but we can run our machine learning algorithm on their encrypted data. Sounds like a weird thing. You're running an algorithm on an encrypted data. So we have a recent paper, my collaborators are Dave Page, Eileen, who was a postdoc here, and Mark Joy, who's a collaborator, where we show how to learn ridge regression models over just encrypted data. Okay. Now the thing here, the key is you need to compute, right? You need to do ridge regression over encrypted data, so you need to compute over encrypted data. And there has been a lot of work done in the last few years, and that field is moving very fast. Okay, and essentially there was this big result in cryptography by Craig Gentry, who got the MacArthur Genius, I think 2-3 years back, which said that you can compute any operation over encrypted data, but it can be very slow. Okay, I'm going to leave you this with a puzzle. I'm going to read that 1 as a 3. Okay, so I'm just going to leave you as a puzzle, and if you send me an answer to this puzzle, I will give you a prize. Okay, so there are end users, each one of them has a salary, and you want to compute their average. And obviously you don't want to reveal the salary. How would you do it? Okay? There's a very simple cryptographic solution, but there's also a non-cryptographic one. And I'm going to just go through now the next slide. Okay? So the idea with clustered machine learning is you're essentially doing machine learning in presence, machine learning or data science, whatever you want to call it, when there's an active adversary present. So now what we're going to do is just quickly go through people who in this department kind of touch security and privacy. Art Miller does a lot of binary code analysis and vulnerability assessment. Qasim Fawaz does a lot of work on building effective, practical, and digital privacy protection systems. You already saw I'm spending almost 100% of my time doing trusted machine learning. And there are a lot of other people who do security-related stuff. Paul Marford does a lot of network intrusion detection, botnet detection. Eric Bach does a lot of computational number theory, which sits below cryptography. And Mike Swift does work on cloud security. Okay? You want to also, when you think about picking a place, you should see that you have enough courses that you can take to get trained. And we do that. Okay? So for example, we have an introduction to cryptography, we have an advanced computer security class, and there is a system security class called Introduction to Computer Security. Okay, so I'll leave you with this. Security research involves understanding and improving the behavior of computing technologies in the presence of adversaries. And if everybody was like Mother Teresa, there would be no security and privacy research, but unfortunately there isn't. And trustworthy ML, in my view, is probably going to be one of the most important topics of our time. Okay? And our department is really in the thick of things. You saw we are part of this big NSF center. and a lot of things going on, a lot of faculty working on it. And I think this is kind of the big challenge problem for the next decade or so. A lot of interesting things to do. So I'm going to stop now. Are there questions, or should we just move on? Any questions? Comments? Everybody likes guacamole, jazz, cat.